Alright, in this tutorial we'll be talking about classes and objects. Now, this subject is particularly important for two reasons. The first reason is that Python is an object-oriented programming language, alright, which means that almost all of its structure is built around the concept of objects, alright? Everything in Python is an object. Integer values are objects. Float values, string values, Boolean values are objects. Lists, dictionaries, you name it. Everything is an object. All right. The second reason is that later on, most of the libraries that we are going to import and work with consist mainly of classes from which we will create objects in order to store and process the data sets that we are going to work with. All right. Again, most of the libraries we are going to use consist of classes. From these classes, we will create objects in order to store and process the different data sets we are going to work with. All right. So make sure by the end of this tutorial to really understand what is a class and what is an object and how to work with these two. All right. Now, what are the main components of any class? Or what is a class, in other words? A class is basically the blueprint, all right, from which we can create multiple objects. Again, a class is the blueprint from which we can create multiple objects. Now, every class consists of two main components. The first component is the attributes or the data fields. It's basically the data contained in a class, all right? And the official name of these data fields is attributes, all right? The second component is the methods. And this basically, methods are basically normal functions like the ones we have worked with. And these functions are used to manipulate the attributes or the data fields that we have created. All right, again, a class consists of attributes and methods. The attributes represent the data fields inside the class or the data, and the methods are basically the functions that we use to manipulate the attributes. Okay, and later on you're going to see how the attributes are nothing but normal variables used to store the different types of data. All right, now let's look here at an example of a class named car. All right. Now, as you can see on the left-hand side panel, we have the attributes of the class car. All right. So, for example, one attribute is the color. The second is the make, year, mileage, speed. We still don't have any actual values for these attributes. We are just defining the blueprint or the structure of our class. Okay. Now, on the right-hand side, we can see that we have the methods or the functions used to manipulate the attributes. So for example, we have a method called the accelerate method, right? And the accelerate method will simply increase the speed of the car. You see how it manipulated an attribute from this class, right? A break, on the other hand, will decrease the same attribute, which is the speed. Read mileage, for example, will get you the current reading of the mileage attribute of the car, right? So again, we still don't have any actual values. We are just defining the attributes and the methods of our class. And later on, we will start creating objects from this class. All right. And here, just to illustrate, here we have only the header of the different methods. All right. But in an actual class, we will actually define these methods the same way we defined the different functions in the previous tutorials. Right? So now that we have defined the class, we can start creating however many objects we want. Okay, so for example, here we created an object called object1 and we assigned these values for the different attributes of this class. So for this object, the color is blue. All right, the make is Ford, the year is 2016, the mileage is 4,000 and the speed or the initial speed of this object will be 0. Okay, now here we can create another object called object 2 with a different set of attributes. Right, so the color for this one is silver, the make is Jeep, the year is 2009, 20,000 for the mileage, and similarly we have 0 for the initial speed of the car, or also of the car object, in other words, right? Now, it's important to know that whatever we do to this object will not in any way affect this object here. They are completely separate entities, but they are instantiated or created from the same original class. Okay, so we can actually create 100 objects, and each object will have its own version of attributes or its own set of attributes. Okay. Now, for each object, we can call any of these methods, accelerate, brake, and read mileage, which will affect or manipulate the attributes specific to the object at hand. Okay, so if we called the accelerate method on an object 1, all right, and we accelerated, for example, the speed attribute by 5, then only the speed of this object here will be affected. All the other objects will remain intact. Okay, so can you see the power of the concept of class? We create the class once, we define its structure, we define this blueprint we have, and then later on we can create as many objects as we want from that class. Okay, again, just remember that everything in Python is an object from a certain class. All right, a string value like hello world, for example, is actually an object from the class string. All right, a list of the numbers 2, 5, and 9 is basically an object from the class list. All right, and later on we're gonna see the implications of this fact through a couple of examples. Okay, now let's take a look at a small class. Let's define this class called car, add in some attributes and add in some methods in the class just to see how we can actually uh, uh, construct an actual class in Python, right? Now to do that, we start with the keyword class. Okay, next we give a name to our class, which in this case is car, right? After that, we place a colon, like, uh, just as the same way we did with the if statement, the for loop, and the definition of any function. Okay, after that, we leave some indentation or white space, and we start defining our attributes and our methods. All right. Now, the first method is a special method uh, uh, that is shared among all the different sorts of classes, which is called the init method. All right, it's basically two underscores, the init keyword or initialize keyword, followed by two underscores as well. Right? After that, similar to any function, we open two parentheses and we pass the first parameter as self. Self is basically a pointer to the current object. Okay, so we always have to pass the self parameter at the beginning of the parameter list here. Okay, now we put a comma and we start uh, 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 defining the rest of the parameters. In this case, we name them co, for example, for the color, M for the make, Y, my, and SP. Okay, now it's a normal function, so we place a colon here, we leave some white space, and then we start defining our attributes. Now, for every attribute, okay, we simply mention the self parameter dot followed by dot, and then we specify the attribute. Okay, so how many attributes we have in total here? We have 5: color, make, year, mileage, speed. Okay, and what values do we want to assign to these attributes? The parameters here. So co for the color, M for the make, Y for the year, MI for the mileage, and SP for the speed. Now, keep in mind, all right, that initially this function will be called automatically the moment we create an object from class car. Again, init is a special function that will be called automatically the moment we create an object from class car. Okay, so when we start creating an object, we must pass some initial values for these attributes. So we say we create the object, and then we pass, for example, blue for the color, Mercedes for the make, 2000 for the year, and so on and so forth. And we're going to see how later on. But for now, just remember that this is an automatically called method within the class. All right. Next, we start defining the different methods we need in this class, right? The first one is called accelerate, right? So we start with the def keyword, and then we named our function accelerate. And in the same way, we pass the first parameter as self. And then we pass another parameter, which we in this case called it mile per hour, all right? Now, inside the body of the function, all we want to do is to access the speed attribute using self.speed and increase it by the number of miles per hour that we pass as an argument to the accelerate method when we call it on the object. Now, I realize that I've said a lot of terms, technical terms here, and I'm sorry for that, but uh, uh, each one of these terms is important, especially when you start navigating the different documentations. So again, accelerate take two parameters, okay, the self and the mile per hour. And then the body simply increases the speed by the number of mile per hour, the number we pass as an argument here. Again, we're going to see later on how this comes into action. Now, next we define another function called brake, which is similar to accelerate, but it decreases the speed by the miles per hour rather than increasing it. Okay. Third thing is a function called read mileage, which simply displays or prints out the current value of the mileage attribute. It simply accesses the mileage attribute and it prints its value out. So if the mileage of a certain object were 5,000, this method simply displays 5,000 or prints out 5,000. Okay. Fourth, we have a function called change color, which simply changes the color attribute to something else. What is this something else? It's the value we pass as an argument when we call this method on the object. All right. Fifth function or method, to be more specific, uh, is the display information function. Let's see the body of this function. This function simply creates a dictionary and compiles the values of the current attributes and integrate them into this dictionary. Again, it just retrieves the current values of the different attributes and put them inside the dictionary. Now, this function return a value. What does it return? The dictionary, the whole dictionary called information dict, which basically contains the attributes. All right, and at this point we are done. We have defined our blueprint, we have defined our class, and now we are ready to start instantiating or creating objects from this class. Okay, let's see a few examples. So here we create an object, all right, and we call this object Ford object. Okay, it's just a normal variable, but inside the variable we will store an object from the class car rather than a value like 2 or 5 or 6. All right, so we name our first object for the object and it's equal to. Now we start creating the object by first stating the name of the class, which is car, right? After that, we open a pair of parentheses and we start passing the arguments or the inputs expected in the init method here, right? So how many does it expect, uh, uh, excluding the self parameter? We have 1, 2, 3, 4, and 5, right? We don't need to pass the first one. It's passed automatically by Python. So we just need to pass 5 values for each attribute. Okay, so we will have blue, which will be the color attribute of of this object. Ford will be, it will be the value of the make attribute. 2016 will be the value of the year attribute, and 4000 will be the value of the mileage attribute, and 0 will be the value of the speed attribute. All right, so this is the first object. Now we want to create another object. Let's call it Jeep object, right? And it's equal to, again, the name of the class followed by parentheses, and then we pass 5 values as expected by the init method, excluding the first one. So here we have silver Jeep 2009, 20,000 and 0. All right, so now we have 2 objects that are ready with initial attributes, and now we can start calling some functions on these, some methods, sorry, on these objects. Okay, so initially, what we want is just to refer to the first object, which is fourth object, and call the display information on it. Now let's look at the structure of this call. All right. So we start by referencing the object name, and then we use the dot symbol or the period. This is important, all right? Whenever we want to access an attribute or a method from for an object, all right, we use the period or the dot. This is gonna become very handy, and you're gonna see it a lot. So please remember that we use the dot to access the methods and the attributes of our object. So we want to initially access the display information method. Now, since it's a method, we need to follow it with parentheses. All right. Again, as I said before, a method is simply a function, but it's called the method within the context of a class. All right. So just to treat it is exactly the way you treat any function we have used before. All right. So display information, we call parentheses, and we are done. Now, what does display information do? It simply adds the attributes to a dictionary and returns the whole dictionary. So we simply will print the whole dictionary, right? Okay, let's print out the dictionary initially here and see what values we will get. See, this is the returned initial dictionary. What are the contents? We have multiple key value pairs, right? The color is blue, right? Make is 4, year is 2016, minus 4000, and the speed is 0. Just like we expected when we first created the object. All right, now let us call another method on this object, fourth object, which is called accelerate. Now, how many inputs does this accelerate expect, or how many arguments does this method expects? Accelerate expects 1 argument, because again, self is passed automatically. So we will just pass the miles per hour. Now, fourth object accelerate 10. So miles per hour is 10. What does this function do? It increases the speed attribute by 10. So it was initially 0, now it is 10, right? Now that we have changed the attribute, let's call the function or the method display information one more time to see if our changes were actually reflected on the object or not. So let's rerun our program and see. See, the first one here have all these attributes. The second print statement with the change accommodated, all right, we can see that now the speed is 10 rather than 0. Why? Because we called the accelerate method on it. All right. Now, let's go down below and uncomment this, which is basically calling the method break and passing 5 on the same fourth object. All right. So let's do that and then call the display information one more time to see if the changes were reflected. As you can see now the speed is 5. So from 0, then 10, then a break, decreased the speed to 5. All right, can you see how the methods are actually manipulating the attributes? All right. Now, what if we call the display information on the Jeep object? All right. Let's see in this case what's gonna happen. As you can see, the last one displays the different attributes of the Jeep object here. So silver, Jeep 2009, 20,000, and 0. So as you can see, the speed of this object hasn't been affected by the different methods we applied on the Ford object. All right. Okay. Awesome. Now, I completely encourage you to actually go ahead, open up your editor, and start creating different classes with different sets of attributes and methods to see how the whole thing actually works. All right, uh, and test it out the way you want to really understand what's happening. Okay, now here let's take a look at this code here, which basically confirms the fact that everything in Python is actually an object. All right? So here we create different variables with different data types, right? So here it's an integer, here it's a float, z is a string, my list is a list, my dictionary is a dictionary, and so on and so forth. Now, after we define each variable, we simply print two things. First is the type of this variable, the type of the data inside the variable, and then we call a built-in function called is instance, all right, which basically compares two entities to see if they are equal or not. All right, so we are comparing each variable with the entity of object to see if they are actually the same. Okay. Now, keep in mind that type is a very important function and you need to use it repeatedly in order to figure out what is the type of data you are dealing with. And this is going to help you a lot in understanding how to deal with the object at hand or the data at hand, right? So we printed out the same statement, same kind of statement for each one of these uh, data pieces. Now let's print out the results and see. All right, as you can see here, right? Uh, and true. All right. So the first one is class integer, right? So integer is actually a class, right? And then the value of a true was printed out, right? Now let's rerun this program as there seems to be a problem. Here we go. All right, so the first one is a class integer, and the value of a true was returned for the is instance function call, right? True means that this is an object. Next, class float for 2.4, right? And true for the question of whether this is an object or not. Third, str for class string, right? And we have the value of true as well. Fourth, we have a list and the value is true, dictionary and the value of true is true. So as you can see, all of these are actually classes, all right, from which we created objects. So when we say x1, we are actually creating an object from class integer. When we say z equals hello, we are creating an object from class string, and so on and so forth. All right. Now, what does this imply? What does the fact that everything is an object actually imply? It basically implies that we can call or use certain attributes and methods for these objects, right? So we can say, for example, for the string value z, we can say z dot, for example, let's see what methods we have here. Capitalize. So we say z dot to access the method inside the class, which is called capitalize. Since it's a method, we surround it by these parentheses. As you can see here, it reads return a capitalized version of the string. More specifically, make the first character have uppercase and the rest lowercase. Now let's see if this actually worked or not, right? So let's print out this value and see. As you can see here, hello with a small letter at the beginning was converted to or capitalize, as you can see here. All right. Okay. Next, let's use a method on, for example, this list here, my list, right? Dot to access the list of attributes and methods. So maybe we can say count what returns the number of occurrences of a value, right? All right, so let's call count and uh, let's see, for example, the value L, right? Uh, let's print out the value, okay, and see. Right, 0. Okay, so count, it seems we called it on my list. It's a function that we called it on the wrong list. All right, my list dot, let's see again the list of functions. For example, sort, right? The initial list consists of the values 206. So let's sort out this list and then print out the list again, right? So let's call our method first and then print my list again. All right, let's see. So as you can see, now the list is sorted with the value 026 rather than 206. Now, this sort function basically affects the original list we have here. Some other functions actually create a copy with the change accommodated into the list, right? So some other functions returns a list with 026 while leaving the original my list intact, okay? Uh, now we can actually access whatever methods we want, right? We can use the pop method to, for example, remove and return an item at a specific index, right? So we can remove the item at index 1 from the list my list, which will remove the number 0. So we'll end up with only 26, right? And use insert to insert a value at a specific index, extend, index, append, and the list goes on and on. Now we can actually refer to the different documentations in order to figure out what are the possible methods or attributes we can call on these objects, right? One resource I have indicated recently was W3 Schools, which is actually an excellent resource. Okay, so as you can see here, we have for the string class, we have this list of methods, right? Python has a set of built-in methods that you can use on strings. So capitalize, center, count, encode, index, etc., etc., right? Here we have in the reference Python list methods. All right, we have append, clear, copy, count, extend, etc., etc., right? Same thing for many other types of objects. So always, whenever you are dealing with an object from a certain class, make sure to refer to the official documentations, or not necessarily the official documentations, in order to see what are the possible attributes and methods you can call on that object. All right. Now this is very powerful, and it can help you a lot in creating very powerful projects and data analyses. All right. So that was it for today's tutorial. I hope you found this informative. Please make sure to subscribe to the channel, and I will see you in the next tutorial. Thank you very much for watching.